Perfect timing. Hello, everyone. Good morning, good afternoon, good evening, whichever part of the day it is. Hope you've all had a good afternoon. We've got, well, good day so far. We've got a bit to get through today, but all sorts of fun stuff. And you can't hear me. Can you hear me now? How's that? Is that better? Oh, okay, great. Can hear me. Don't want to not hear me. That's quite important. Okay, great. Excellent. Let's do it. So, okay, I'm not going to start going on tangents to start with. I'm just going to go through a few of the lecture notes that I don't lose it and start going here, there, everywhere. So, today's lecture is going to be, okay, yesterday we continued doing linked lists. Today we're going to finish off just that little bit because I realized I forgot to show you the leak check stuff, and we're going to finish that move head to tail, tail to head thing if we feel like it. And then I promised you to do some copying of a list. We can look at that as well. I kind of tried to do it as though it's an exam question as well, so we'll talk about that. You just wait about the exam. I will talk to you about the exam in a second. I'll tell you what you get in the exam. I'll tell you what you don't get in the exam. Don't worry, there's going to be like 30 minutes all about the exam right now. Okay, so today I'm going to talk to you about the exam. So you're going to get the format, the preparation, some hints and tips. I'm going to give you some kind of like understanding of what the questions look like potentially, of what, as in like different types of questions and what they look like and how they go. Okay, great. So let's see, that's going to be where I put the live lecture code. And there's quite a bit in there that's not, you can't see it yet because I have not given you access to view it yet. As we go through it, I'll make sure that you can read it and see it and stuff. Okay, so one thing that has happened is that my experience feedback is out. And we ask all of you to complete this course feedback, this my experience surveys. So the university uses this and we use them to make the course better. So you basically review the course and then you review your tutor and you review me. Keep your feedback constructive and to something that can be potentially improved. So we definitely use the results of these to improve the courses all the time. And we're very, very kind of like, I really like seeing the feedback from these, and I like putting into action something that, you know, was said to me that I maybe not have realized throughout the term was happening, and then fixing it for the next iteration of the course as well. So my experience is very important, so please do it if you can. Mucho, very much appreciated. Okay, let's talk to the exam. Let's not talk to the exam. Let's talk about the exam. Okay, so the exam, everything that we have learned so far. So I guess that's not really rocket science, but to be nice, we are not going to be learning anything else that's new from now on. It's all just going to be revision for next week and stuff. I'm not going to be introducing new content and surprising you with it and being like, actually, this is all on the exam. Good luck. May the force be with you. Nope. So we're done with new content. And everything that you've learned so far. So there's lots of focus, obviously, on if statements, using your variables, using your while loops, strings, arrays, pointers, linked lists, right? And especially arrays and linked lists. They're a huge part of this exam because they're your hurdles. So the date is the 5th of May. So that's going to be super exciting. You should have gotten your timetable out as well now, so you can see it on there. The CSE exam, the COMP1511 exam, will not be obvious what time it is because it'll kind of say like, oh, it's like a whole day or something like that. There are 2 sessions of the exam because there are so many people. We can't fit you all in at once. So there is a morning session and an afternoon session. you will receive an email that will let you select which session you would like to choose. If you have an ELP that says that you must have a certain session, you will just be placed into that session without a choice. And if you don't choose anything at all, if you don't reply, you will be automatically placed into a session that has time left for you. So even if you don't reply, you're still sitting the exam. Don't worry, you're not going to miss out on the exam. So because we have 2 sessions of the exam, right? Those, and they're going to be the ELP exams are on the 5th as well, right? We have separate rooms and whatever else for the exams, for the ELP students. So, and whatever is in your plan, it will be put into practice during the exam as well. So the selection you should be able to select in week 10 and at the latest in week 11. That comes from the exams team. It doesn't come from us. So they're the ones that will organize the seating. And for those that are sitting the afternoon exam, you're going to be corralled in the afternoon for about 20 to 30 minutes. What that means is you have to show up to your exam at the time that we tell you to show up. So and for 20 minutes, you will all be placed into a room so that you do not see the people that are leaving the exam and you do not cross over with them. That's what corralling means. It means that we keep you in a room and you cannot communicate with anyone that has just done and finished and left the exam. So you will show up to the exam. You will be told for the morning session, you will be, the morning session will be given kind of a seating. They'll be told where they're sitting. The afternoon one, you will be told at corralling where you are. Okay, so you'll get the email either at the end of week 10 or you'll get it at the very start of week 11. Don't stress, it's going to come from the exam team. The morning exam usually is 9:45 to 1 o'clock. And then corralling 12:50 to 1:20, and then the afternoon is 1:20 to 4:40. So corralling, the doors shut at 1 o'clock, right? So there's 20 minutes where you're shut in the room, invigilated room. So you have to arrive by the time the doors shut. So please, please, please be on time for the exam and even a little bit early, right? Please, please don't. If I tell you what happened to me during my very first computing exam, I don't think I'm traumatized from it. I did not make the exam. I slept right through 3 alarms and I was too late to the exam. I wasn't allowed into the room. So don't sleep through the alarm, set a few alarms. That is traumatizing to bits. The morning exam, yes, thank you, Bella. You cannot leave the morning exam early, but you can leave the afternoon exam whenever you want, basically. And yeah, but the morning exam, you will not be allowed to leave early because of the corralling situation. So you have to leave when the exam finishes. You're in there and you're sitting for the full 3 hours of the exam. So definitely no phone in there. In the corralling, you will not have access to your phones, and we will ask you to then put all your bags and phones at the front of the room that you go into, right? So phones will be away, but you'll still have your bag with you. But yeah, not during the exam. You will not have your bag with you. Okay. One thing actually I want to say that's not in the slides is that when you come for the exam, you need to, no, there's no paper notes, just wait, I'm coming to that. You'll just, I'm coming to it, no paper notes. You will have scrap paper during the exam, but I'll tell you what you have during the exam. Sorry, Sophie. Okay, next week you have your lab exam. It's a practice exam, right? It's so that we can see that everything is working for you in the exam environment, okay? So when we go into the exam environment, in the corralling room. Yes, you can have some paper notes in the corralling room. Yeah, sorry, Sophie, I didn't realize what you were saying. But not in the exam. Yeah. Okay, so it's basically a practice exam next week during your lab time. We count it as your checkoff. We want you to show up to and log into the exam environment so we can make sure everything is working for you. And also so you can get a feel for what the exam looks like in the exam environment, right? So you'll be able to actually see the system, you'll be on the computers that the exam is on, so you'll really get a good feel for it. The other thing that I would like for you to do is I would like for all of you to make sure that you have your student identification card, okay? Because to sit the exam, you need to show your student ID. And it's really, you will have to be sent up to me for another form of identification if you don't have it, but please go and replace a lost student ID before the exam. So go and replace it next week before the exams start, in week 12. Okay, so next week you're going to have that practice exam. The practice exam is going to be, it's actually an old past paper, so it will give you an idea exactly of what the exam looks like, okay? So it's going to be the actual exam paper is going to be very similar to that, and we want you to get a feel for the setup. So give is going to be the same. Auto tests are going to be run in the same way. You can submit as many times as you want. Only the last submission is marked. The only difference is we do not keep track of any of your auto tests. So you need to submit your final answers and your code. And we will remind you of that over and over again. Please don't forget to submit. That always gives me the hives, thinking that someone's forgotten to submit. We do send 2 or 3 reminders throughout the exam for you to submit. So you can submit as many times as you want. Only the last submission will be marked, but you need to submit for us to be able to see some code, right? So please don't forget to do that. Okay, so we try and give you as much practice as possible so that you do not kind of get stressed when you walk into the exams. Exams, by definition, are a slightly stressful environment. So, try and kind of use it as a bit of exam practice and a bit of practice in sitting exams as well. And it takes practice to kind of do exams and get better at exams themselves. It's not, I think the whole process of actually sitting an exam is not that simple in itself. That's without even talking about, all the content that you need to know as well. So you will need to log into our exam environment. You will not need your phone for the password in this case. You will not need to authorize because it's our exam environment. All you will need is to have your student ID, and the student ID will have to sit on your desk so that we can see you are who you are. And you might need a pen to write on that scrap paper that we have given you. I'm about to talk about auto tests. That does not mean that. If you have auto tests and all your auto tests are passing, that's a very good indication that you're going to do very well in the exam. But there are some tests that are not on auto tests, particularly for non-hurdle questions. All the edge cases are usually not on auto tests, but we do use them in marking. Also, you can hard code your answer and pass all the auto tests. So that does not mean we ask separate tests to catch out anything like that as well. Okay, so the most important things you have to do in the exam is you have to pass the hurdles, okay? So there is an array hurdle, which is your question 2 or question 4 in the exam. Both of them are clearly marked. What I mean by saying pass is that you need to get 50% on one of those questions, okay? So not on both of them, just on one of them. You need to get either 50% on question 2 or 50% on question 4. I mean, feel free to get 100% on both, right? I'm not stopping you from doing, but what I'm saying to pass, you need to get that 50% for the hurdle. There is also a linked list hurdle, and the linked list hurdle is question 1 or question 3. So we start you off, the first question is linked lists because that's what we've been doing in the last bit. So I think maybe to get you a bit more comfortable, you start with a linked list, then you go to an array, then a linked list, then another array. Then I'll talk about what the other questions look like. Absolutely do the hurdle questions first, and then you can do whatever you like in whatever order you like. But make sure to have 2 hurdles, final, an array and a linked list hurdle passed before you start throwing things around and kind of going in whichever order you want. Okay, so same thing with the linked list hurdle. You need to pass either question 1 or question 3, which means you need to get at least 50% in either question 1 or question 3. Okay? So yeah, all of these questions are clearly marked on the exam. Okay? Everything is clearly marked. Okay, it is a closed book exam, which means you can't bring your notes and you can't, bring everything, everything in the kitchen sink in there. But our course website will be open, and you will see that next week when you do the hurdles do have marks, and I will go through how much they're worth in a second. So closed book exam, but our website is open, which means that you have access to any lecture material or code, any tutorial material or code, and any lab material or code. So all the solutions are available to you. I strongly don't recommend using that as your like crutch, because the exam is too short. You will not have time to suddenly learn all about strings during the exam to answer one single question. Okay? So you need to know maybe the rough arrangement of how the questions or how the weeks flowed, what we did in each of the weeks. But other than that, it's there just in case you've forgotten, a little security blanket, but not enough time to actually go and like delve deeply. Maybe you forgot a little bit of syntax. Well, it's available to you in any of the lecture code that we've done. So you don't have your own labs available, but you have our solutions to the labs available. You will bring your own pen, but we give you some scrap paper. No, if you get 20% in one hurdle and 30% in the other hurdle, it does not get added up. You have to pass one of those questions. You have to show enough understanding of a hurdle to pass one of those questions, either one. You cannot bring headphones unless you have a like an ELP or a special consideration that allows you to do that. You can contact them and ask if you can bring those foamy ear things that go into your ears. I can't remember what they're called. I agree, the clickety click of keyboards, and I always find it annoying when people are coughing, which I seem to do a lot of. But yeah, you can't have anything extra on you unless it's in your unless it's in a provision. And same, so earplugs, you have to make sure that they're like those little yellow foamy ones, basically, and we can see the packet that they make sense. Okay, exam conditions still apply. What that means is you're not leaning over to the person next to you and you're having a bit of a chat with them as well. When you leave the exam, do not communicate with anyone about the exam. So don't go on Reddit and start talking about the exam. That's considered plagiarism, right? We don't want anyone to talk about the exam within 24 hours of start time. You will get scrap paper for working things out, and you can ask for more scrap paper if you want. If you have been doing your labs, if you've been doing 1 and 2 dot labs, and if you've been doing your own assignments, you will be able to pass the hurdles, right? There is nothing that's going to trip you up or trick you. The exam is not designed in a way that's let me find out how I can stuff them up. Not like that at all. It's more like, let me see what they have actually learned from the things that we've actually learned. So yeah. Okay, so no discussion of the exam, sharing any of your code except for COMP1511 staff. So yeah. So someone said, I've no idea if we pass auto test how we lose marks. It depends. It depends if you forgot an edge case. So like, remember when we talk about linked lists and I'm always like, oh, what about doing something at the head of the list? So let's say you forgot to say if head is equal to null, then do this. And that's an edge case. There was no auto test for it, but we do test for it when we mark. That's how you lose marks, right? So you've forgotten an edge case basically. Okay, the reason it's considered plagiarism is because you've gone out and you have discussed what questions might be in the exam, but someone might be sitting the afternoon exam. Not that you're allowed to leave early, But you are allowed to say, how did the exam go, but just don't discuss the actual exam questions to start with. Yes, I review your code after submission. That is a lot of code reviews. So anything that doesn't get full marks in the auto marking, I will look at it manually to make sure and to mark it manually. Yeah. Okay. Not always. I'll talk to you about how we build the auto tests up for the exam. Yeah. All good questions. Now, if this is all the time, something happens in the exam, you don't raise your hand, you don't let anyone know, you walk out of the exam, and then you write me an email that says, well, during the exam, my monitor froze, and then my keyboard wasn't working, and so I couldn't really do anything about it. At that point, I can't prove that that has happened, and it's too late for me to be able to do anything about it, right? If something is happening in the exam, okay? If something has happened in the exam, your screen is freezing, your keyboard is not working, you cannot bring your own keyboards. It all has to be the ones in the lab. If your mouse is not working, if your chair is not working, I don't know, right? Raise your hand and let the invigilator know, because we can fix things in the exam. And if your keyboard is not working, for example, we can give you an extra 10 minutes whilst we change over the keyboard. You have to raise your hand in the exam if something is going wrong. Yeah. I'm about to answer all of your questions. That's why I'm like, just hold on, I haven't gotten up to that yet. I'm about to answer every single one of your questions, I swear. Okay, next. So when you come into the room, you seat yourself. There's going to be some instructions provided to you. You cannot wait for the instruction to commence the exam. Okay, so don't just start the exam before you're told to start. You'll fetch the exam as usual, and the same way you've been fetching things before, and that fetch will get you all your starter files and have it all ready. You know what? Do you know what would be really good actually? If we have an exam FAQ, is there one on the forum? I can't remember that no one ever checks. Let's do that. Let's put it on the forum, and then we can move it, and we can, and you can, you know what? I'll do a form. Let's do forms. Every question in the exam is clearly marked. If it's 1 dot, 2 dots, 3 dots, or anything more than that. So you will be told throughout the whole exam what the question rating is. If the whole term you've not been able to do a single 3-dot question, please do all the other questions first. Don't start and sit with a 3-dot question trying to do it and then lose time and not answer any of the hurdles, okay? So please be logical in the way you approach the exam. I think, yeah. Okay, now the University of New South Wales has something called the Fit to Sit policy. What is the Fit to Sit policy? Basically, by coming in, sitting down and doing the exam, you're telling the university that you are fit to do so. And that means you cannot later apply for special consideration. Okay, I have some caveats with this, okay? This definition doesn't give a lot of flexibility there. However, okay, if you wake up on the morning of the exam and you are not feeling well, you've got a cough, you've got a fever, you've been vomiting, whatever, right? Do not come to the exam. Go to the doctor. Get a medical certificate. You will absolutely get a supplementary exam for medical reasons. The reason I tell you that is every year someone shows up, I get vomited on, and then I spend 2 weeks in bed sick because someone has just vomited on me. Please, if you are unwell, do not come to the exam. You are not feeling well. Rest. Go to the doctor, and get a medical certificate for that time. Also, if you're sitting in the exam, okay, everything happens, right? Suddenly, you do not start to feel well. You feel awful. Maybe you feel like you're going to vomit. Maybe you feel like your fever's gone up. I don't know. but you're suddenly starting to not feel well, raise your hand, tell the invigilator. We will make sure that you go to the well-being center or the doctor to see a doctor to get a certificate to then be given a retroactive special consideration to sit a supplementary. Please do not push through if you're not feeling well. That doesn't go well for anyone, right? Please, please, please. Oh, look at that. So I tell you that. So if you feel so unwell during the exam, please do not continue with the exam. Stop working, raise your hand, tell the invigilator, I will come and see you. Please don't vomit on me. I might give you a vomit bag if you do want to vomit, but do not vomit on me. And then within 24 hours, you need to submit that special consideration with a doctor's certificate, okay? So please, 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 if you're not feeling well, do not come to the exam, okay? Is that okay? It's one rule I want you to walk away from. If you're not feeling well, do not come in. I do not want your lurgy. Okay. Now, if you do get the special consideration, there is something called the supplementary exam. And the supplementary exam is held usually in the week of, in O week, basically, in the O week before the term starts. So if you need that exam, you need to make yourself available. Okay, that means you cannot be like, oh, I can't make it to the sup exam, because there's not many options after that, right? So please, 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 that's the details of the dates. So keep that in mind. We'll be running some revision classes, so keep your eye out on that, and for all the registration and the details of that. I'm about to go through the marks. Okay, format of the exam. You're all way ahead of me. I don't know how fast I can speak. Penny's done. Penny's done. It's now, yeah, poor Penny. I think I've eaten chicken every day. Well, it's only Tuesday for the last 4 days. So that's Penny. Okay, so the exam is going to have, 11 practical answer questions. That means that you are going to be on the keyboard in the lab. They are practical questions. You are coding in the lab environment. So your question 1, question 2, question 3, and question 4, those questions are your hurdle questions, okay? The hurdle questions are worth, let me move my camera. I am now in the way. How's that? That's better. So the hurdle questions are each worth 12 marks each, okay? They're programming questions. I'll show you examples of them in a second, and I'll tell you exactly kind of what they're looking for, okay? You please do not do other questions first before you do. Please do the hurdles first, okay? Because you've got to pass an array hurdle and a linked list hurdle to pass the exam, okay? You don't need to get a 50 overall in the exam to pass it, but you need to pass the hurdles. Then question 5, question 6, question 7, and question 8, they are kind of like debugging questions, right? So they require you to understand what pieces of code are doing, interpreting code, fixing some bugs, right? They are 5 marks each, okay? So they're worth less marks. You're not coding per se, but you're debugging some code, okay? Because sometimes we do one which requires you to interpret a diagram. That's why. Yeah, it might be a linked list diagram, and then you have to actually, implement it. But you will see examples of these questions in the practical test. The questions do get progressively harder, indeed. Questions 9 and 10, they're 11 marks each, but if you notice, the marks for them start going downwards as well. So it's not, They are programming questions, and I'll talk more about them in a second. And then you have question 11, the final question is 10 marks each, and it's another programming question. So they are similar in style to the questions you do in your problem sets across the whole spectrum of, 1, 2, and 3 dots. They're all rated as well. It would be nice if you can attempt the first 8, but I really, really want you to do the first 4 questions if possible, because they are the hurdles. Okay, so now I will talk more about each of the exams, each of the questions. Okay, don't worry, I'll describe them in detail. It's question 5, 6, 7, 8. There's 4 times 5. There's 20 marks for these ones. Okay, so let's talk a little bit more about that. I do not scale marks. Whatever you get is what you get. I do not use scaling at all, ever. I think it's just I do not scale at all. No scaling. Whatever mark you get is the mark that you get, okay? Style does not get marked, but I am looking manually at your code, and if I look manually at your code and I cannot tell what you're writing because your style is so bad, I cannot mark it properly, okay? So keep it neat. I don't care if your variable names are rubbish. Well, I do care because it makes it hard for me to give marks away. But yeah, same as, when you were doing the HSC and you had to handwrite something and they kept telling you if your writing is illegible, no one can read it. It's kind of similar to that. If your code is illegible, I can't read it to give marks. So just keep that in mind. Okay. So I've kind of talked about that. Okay, harder questions will have less auto tests. So this is what it means where questions 1, 2, 3, and 4 usually have quite a full suite of auto tests, okay? So they give you a good idea that you are doing well. However, getting full marks on auto tests does not guarantee full marks in that question, because we will check whether you hard coded. We will check whether you by accident got a result, right? So sometimes we'll have a function stub, and just as the function stub is, it'll just have like return 1, just not like that was the stub, right? There was nothing to it. But that met like 2 of the auto tests. So you passed it, but you haven't actually written any code. You're not going to get any marks for that, right? You get marks for the code that you write and the code that works as well. You do not need to add any comments to explain your code. Definitely no comments. Unless you're doing question kind of 10 and 11, the harder questions, and you would like to write comments about some of the harder functions that you're doing, I appreciate that. I've in the past also liked to read for question 11. I like to read if someone is telling me their logic and how they think they will solve a question. I like to read that. Why not? Do I read every response? No, I don't read any responses that get full marks on our auto marking, because that means that I don't need to read them. I would go insane if already there's a lot of marking, but we do anything that has not got full marks is read by a human, okay? Okay, so okay, so we've got, so question 5 to 8 in this coming exam will be, if you fail, you have to redo the course, right, in T2. It's not pleasant. And that means you can't take the courses that require 1511 as a prerequisite. So you have to rearrange the progression of your degree, basically. And the hurdles are there to ensure that you have enough knowledge to be able to survive in 1521, right? They're not there to just be mean. They're there for a reason. And the reason is that we don't want you to go into the next course and then really, really struggle in there as well. I like that pity marks. It depends. Pity marks, not overall pity marks, but there are marks sometimes in a question 11. Depends if you're approaching it the right way or you're thinking the right thing, maybe. You do not need to get 50% in the exam, but you need to pass the hurdles and get 50% on the course overall. Yeah. Okay. So the practical questions, that's not five, I just showed four. 5, 6, 7, and 8. So in this coming exam, they're going to be more of the debugging style of questions. So in the style, and this is just me letting you know, there you go, there's going to be no diagrams. So don't worry about diagrams in this particular one. But it's going to be basically debug the following code to make sure it works to produce the desired output. You will see an example of it next week. Okay. Okay. So next, so the exam is 40% off your total mark. And I do love when someone writes something funny in the exam. It breaks up the monotony of marking. But don't feel like you have to, right? But sometimes people will write something really funny. You haven't met Conrad because he's online this term, but he's very tall. And one time he was one of the invigilators for the exam, and someone had like a whole paragraph about how tall the invigilator is. He's so tall. And he was like, every second comment was about how tall he is. I don't know why that made me laugh. It just cracked me up. Okay, sorry, I don't know. That was a completely pointless tangent. Next, when you fetch your exam, it will also grab all your starter files, okay? So not all the files will have starter files, but your question 1, question 2, your hurdles will have starting code. Yeah. So when you have, I don't know, I'm reading the comments as well. Okay, so please read the question before you start. Such an important thing that everyone always forgets to do. Everyone always gets stressed about time, then they just like power on. Read the question, understand what the question wants from you, and then you will be able to actually, start the question. So start with the easier question, go in order, don't go down to question 11 and think, I've got this, I'm going to do question 11 first. No, do the hurdles first. Start with question 1. The questions build in difficulty. Except for the debug questions, they can go either way, depending, sometimes, you've done debugging. Sometimes it's a very annoying process. There is going to be an invigilator at the front that is going to have time written on the board, and they will let you know at a few of the marks how much time is left, basically. But there are clocks in the labs that you can look up to see, and they will have they'll write the start time on the board so that you can see what time you started the exam. Okay. Yep. So less questions answered completely is better than more questions partially answered. This is very important. Okay. Please do not just answer every single question 2 lines. So more questions done completely. Less questions done completely is better. You cannot have a watch because of smartwatches. Yeah. Apologies very much. What else are the questions? Okay, yep. I think we've all answered that. Okay, now let's talk a little bit. Is this when you're told like the points of the time that are given? Oh, reading time. Oh my God. I've stuffed reading time up twice in the exam, so let's never talk about reading time. It's meant to be 15 minutes of reading time, but it has been 10 before, and then we had to make it 10 across the board because on the day of the exam, I think I lost my mind and made sure it's 10, and then one time, anyway, 15 minutes, yeah. Okay. The exam is invigilated, okay? That means that there is someone walking around and having a look to see what you are doing. Not like staring at you, they don't care what you're actually doing, but we want to ensure that the exam has some integrity going. So please don't do anything silly. We will find you. And I really get very sad having those conversations with people. It's really just much faster to study for this exam, and just pass the hurdles. I strongly recommend. Okay, so questions 1 and question 2, your very first 2 questions that you start off. They are 1 dot questions, okay? They will be similar to the practical test, question 1 and question 2. Question 1 is a linked list, and question 1, just wait till we get to question 3 and 4. Question 1 and 2 do not have insertion or deletion, okay? Question 1 and 2 will be simple things. So linked list, it means you might have to traverse, you might have to find some sort of nodes, you might have to count some sort of nodes. You have to do something whilst you traverse the linked list. Arrays, the hurdle is also you might have to traverse a 1D or a 2D array, and you have to find something, or you have to count something, or you have to figure something out based on something in that array. So you'll have your if statements, you'll have your while loops, you might have some simple structs, maybe or maybe not, and obviously you're going to use your variables and stuff. Now, then we go, I give an example. I give a few examples, which we'll also work through. Today I've saved for linked list questions. Then on Monday, we'll do array hurdle type of questions. And then Tuesday, we will do the harder strings questions and stuff like that. So given a linked list, print out the smallest value in that list. This is probably on a simpler side of a 1 dot, and it might not be as simple as that, but just to give you an idea of what it might be. Or it might be given a linked list, count how many square numbers there are in the list, and without using the maths.h library. Okay, and then you'll have to edit the function. Given 2 linked lists, return the difference in the number of items in the 2 lists. And we will do all of those as examples as well, plus more, right? So those are all considered 1 dot. So all of them, what they have in common is that they traverse a list and then they find something, right? So they're not inserting or deleting anything. For your array ones, you might have a struct, you might have to loop through an array of structs, you might have to gather some type of information about it. Or you might have to loop through a 2D array and gather some information. So for example, count the number of multiples of 7 in a 2-dimensional array. Right? So again, some sort of condition, you traverse the array, you find something. So traversal and finding something based on some sort of condition. Amazing. Then we come to questions 3 and 4. Okay, these are now edging to 2 dot questions. Okay, so again, similar to the practical test question 3 and 4, 3 is the linked list, 4 is the array one. So if you have at this point answered question 1 and question 2 fully, and you have passed all auto tests or passed, you know that the questions, your solution is giving the right results, it means that you've passed the hurdles of the exam. Anything from that point on is now bonus marks, okay? They are ways for you to get more marks, okay? So 1 and 2 is the way to go to pass those, and then the stress is removed and you're just getting marks in the exam, okay? So 3 and 4, they're harder applications of the hurdles. That means that you need to know everything that you've done in 1 and 2, plus you might need to loop through more than once if you've got an array. In question 3 for linked lists, this is where you would insert or delete nodes, okay? So that's the harder concept. And you might need to test more difficult conditions, maybe keeping track of more than one thing, or maybe, doing a few traversals of a list or of an array, depending what's going on. So does that feel manageable, the hurdles? Have I cooked everyone, or everyone's feeling good? Feels good. Feels like, yeah. Yes, they do. Okay, then you get to question 9 and 10, and that's when we start to decide, you know what? Things have been a little bit too simple for now. Um let's just have fun with some three dots. Okay? If you have up to this point done all your hurdles, you might have done your debugging questions, whatever else, you've gotten quite a few marks for this exam at this point. Okay, I think you've gotten a credit at that point. 48 plus 20, 68. So you're sitting on a credit at this point already, right? This again is bonus marks. Okay, don't stress. This is not high school anymore. You don't have to do every single question. You don't have to get full marks in every single question. That's not how it works, okay? You do as much as possible, okay? But no stress. Please, no stress. It's just an exam in the end, okay? And it's just one exam for one course, okay? It does not make you like this course or the exam. It does not define who you are. It does not define, anything about you. It's just one exam, and there's more important things in life, okay? Just come in, hopefully pass, give it a go, and move on, right, to bigger and better comp courses and other things. Okay, yes, the lab exam next week is the only thing for your labs in that week, and we will, even after you do that exam in the lab environment, we will still make that exam available to you off the exam environment as well, so that you can go and you can practice, right? So you can go and you can practice and see a prac exam anyway, right? So the exam environment, we want you to log in to make sure that you're able to log in. Okay, so question 9 is usually a harder manipulation of arrays. That means that usually it's strings, okay? Maybe some FGETs, maybe some string manipulation, and we go to town with that. Question 10 is usually some sort of harder manipulation of a linked list, okay? You might use malloc, you might use free, you might have structs, you might have pointers, you probably have no starter code. It's a wild west for a question 10, okay? More complex combinations, maybe some interesting problem solving. So I think question 9 is still kind of going well. Question 10, question 11 are much harder questions, okay? So question 10, and then we go to question 11, which is a mixture of a 3 dot and a skull. Right? So it's a little bit of a combo. You can get a HD mark without doing this question as well, okay? So it's not a necessary thing to do to get a HD. Don't worry about that. But for those aiming for a HD or higher or whatever else, there's no higher you can get than a HD. You will do this question. It will be everything that's taught in the course plus some. You might have some of those harder exercises that are just for fun, those challenges, and much harder and more interesting problem solving. And again, the prac exam will have an example of that question 11, so you can kind of feel the difficulty level. And question 10 and 11 are both really fun questions this year. Obviously a very biased opinion, but super fun. And all of the questions have partial marks, okay? Partial completion of this question does award marks. It's not all, it's not just all or nothing. Okay. Great. What should you study? Everything. You should study everything that we've studied so far. But the best way to study for this course, okay, is to do lots of practice questions, okay? Just reading about things doesn't quite, you got to practice it yourself, right? And the thing with coding is it's a large time drain and a large time investment to understand what's going on and to try things yourself and to kind of play around with things. So you do need to sink the time in to get better at it and to learn how to approach problems as well, because you see You see different types of questions, so you learn how to approach different types of answers. Do we know roughly what percentage gets each grade? I do know roughly, but I don't like giving that information because it's not important. The important thing is just to do your best and kind of go with that. The exam is usually the worst performance out of all of the components of the course, but I always think there's an added stress of the exam, and then you're not in your own environment, blah blah blah. But it's important to be able to function in different types of atmospheres. Okay. What's the pass rate for this course? I also don't like to advertise that because it depends, right? It changes. It changes term to term based on who is in the course. So term 1 usually has the best pass rate because you're all computing majors. You're hypothetically here because you like computing. Term 2 is not as good, but still quite good. And term 3 is usually non-computing majors, so it can fluctuate. So, yeah. Okay, so everything, and then some, what else can I tell you? What other questions have you got? What else can I tell you? I think I've already said all of this. Often the input output, we will do the printf statements, but not for question 10 and question 11. So just make sure your printing matches what our printing is, even though if you have done that and you got a wrong new line, you'll probably still get all the marks for that when I mark it manually, because I don't care about you printing a new line. Okay, yes, you will have a string question. It'll be question 9, usually. You do not have DCC help, you just have DCC. That's a very good question. So just the stock standard, well, our compiler, not even the stock standard compiler. And not autotest help, nope. Okay, and why did COMP1511 and COMP1911 combine into 2 courses? Because it was better that way, maybe. Worked better, yeah. Same lecture content, yeah. And then 1911 people don't need to do the linked list hurdle, so it makes it easier for everyone. Yeah, and DCC will also catch. It tells you where you get the error. DCC also tells you if you've got a memory error. You will not get a seg fault with DCC. So DCC tells you a lot of things. Yeah. Is COMP1521 as much fun? Again, a very biased opinion from me. Okay, so yeah, marks will be earned for correct code, not for passing auto tests. So I'm just going to underline it again. Underline it. Yeah. Passing all auto tests does not mean that you have succeeded in, passing or getting full marks in the question. That is not what it means. Correct code means that, not passing all auto tests. And if you have minor errors or whatever else in your solution, you will only lose very minimal marks, right? It's not, you're good. You are good. Okay. Make sure to breathe in the exam, please. And touch grass. The exam is just the exam for one course, one subject. Some parts of the exam are very, very hard. If you are not feeling the vibes of question 9, 10, 11, don't look at them. Start from the start and just go through one by one. Okay? Please, please, please. You do not need to complete every question in order to get a great mark in the course, right? You actually don't. You can do half the exam and still get a fantastic mark in the course, right? The exam is only worth 40%, but you do have to pass the 2 hurdles, okay, to pass the whole course. Please. So please, 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 and in the lead up, so draw diagrams, think about what you're going to do. No, not here. I'm not ready for break time yet. So when you're struggling to understand something, please draw some diagrams. Please go over all the problem sets. I always say like a really good way to study is to go back to the first labs. And if you use some sort of help to do them, you should try and do them yourself, the 1 and 2 dot ones, okay? And that's your practice, just figuring out how to do them and getting through them, okay? You will get a piece of paper, scrap paper to draw, and if you need more paper, just raise your hand and ask for it. Yeah. Yeah. Okay. Okay, what else? What else? Okay, any other questions? A pen, your ID card, and a see-through water bottle. It can't be like stuff on it. A see-through water bottle is fine. Yeah, and there's revision questions on the website as well that we provide, so do them as well. What does hard-coded means? It means that I can see the auto test is testing to output for like if the, I don't know, question is one thing, output this particular printf, and then I will literally write if this is equal to 5, then printf 6. That's what it means. So you're not actually doing any logic to solve. You're just coding for a very specific case. Debugging questions, yeah, they're probably all 1-star difficulty. Yeah. All right, we're gonna have a 5-minute break, okay? And then we're gonna come back. So 3:02 now. We're gonna come back at 3:10. I don't know how I prepared so many linked list practice questions, but we'll see how we go. Okay, and then we'll do a Kahoot as well. All right, so 5-minute break, and then we will come back to continue. You can have a little short. Look at that, isn't that cute? It's a llama, because you get less stress when you touch a llama. I don't know, a little bit of chat if you like. I'll play you some music. It's all happening. Or I'll play you an ad. I don't like this music. Next one. do one more little song whilst we wait for Kahoot to fill up. All right, it's party time. I am choosing the background music. Thank you very much. Bella's now become goat water. I like that. Okay, Kahoot time. Let's do a few more on here. Let's get a bit of music going. I'm bobbing. Shouldn't really be bobbing that much, just Kahoot music. Oh, no. I'll move myself. Scopes. That's good. All right. Should we start this party? Yes, for an exam question to be marked, it needs to be both auto-tested and submitted. Yes, thank you. I want you to walk away with one piece of information, and that's please submit. And let's commence. That was a really bizarrely kind of ending. Okay, who's on top? Blue rabbit. Blue rabbit. Why am I got my camera on? No one can see anything. traversal is moving through the list. Yeah, I just switched off the camera. I switched it on for my bobbing and then I forgot to switch it back off. Okay, blue rabbit, helpful owl. Let's see the next one. To traverse in one direction. Next. Even when we keep a hold of previous, it's like we're only doing it as a variable pointer. It's not part of our node definition. So because our node definition only has data and a next, we're only going in one direction. You could have a node where you're keeping track of a next and a previous, right? That's now a linked list in both directions. Alrighty, then. Blue rabbit, still on top. Next. Why is the music? Oh, there it is. So when you insert a new data node, you might have a new, you'll have to malloc some memory for it. Very good. Blue rabbit. Nope, no more blue rabbit. Phenomenal meerkat. I'm always happy when it's an animal I can pronounce. Amazing. Woohoo! One after another, continuous. So each piece of memory comes one after another without any breaks in between. Yeah, contiguous is a word that means continuous. It just means that the pieces of memory are right next to each other. So arrays are contiguous and linked lists are not contiguous, because when you malloc some memory, it doesn't have to be next to each other. It can be anywhere where there's a piece of memory to, and that's why we have that next, because that next allows us to know where that, that's why we have a node when we return a pointer to the memory that we created. There we go. That's what I'm trying to say. Sorry, my earring fell out. That's why I'm also trying to fix my earring. Excited chicken. That is a very cool name. Next. Yeah, these questions are now rough. Sorry. I thought they were a good idea. Just a mini exam at this point. Sorry. The music has changed. The vibe's really changed. It's a weird vibe for a Kahoot quiz. Wow, that was really a that anyone goes there. That was quite spread out. I hope it was the fact that you didn't have enough time. I don't, but it's, yeah, it's basically tracking the nodes, but it's until current next is not equal to null. So it's not going to count the last node. It's only going to count, okay. Who's on top? Excited Chicken, still there. It's exciting. Here we go. One more code question. Zoe. My favorite. Come on, I want to see you get it all right. I'm obsessed with this. Compile time error is an error that you cannot run the program. And runtime error is you can compile it, it won't give you an error. But when you run it, it gives you an error. So usually memory errors are runtime errors. And this is a runtime error because the list is empty. And here you try and access it. When you say the next part of it, you try and access empty piece of memory. So compile time is not it. Here we go. Next one. Diplomat coral. How's that an animal? Is that an animal? I'll have to look that up. Next one. What it looks like. What does a corral look like? Oh, it's a coral. Like I understand what's going on. It's not a corral, it's a coral. And they are considered to be animals. Oh, fascinating. I never knew that they're considered to be animals. I'm gonna fixate on this now. Okay. Oh, that's pretty good. Well done, team. Excellent. Who's on top? Blue Rabbit has come back after like 4 questions. Impressive. Last question. I really used up every character of this question. Very doom gloom music. It's this line here. And it's because it's not going to free the last node. Boo. All right, that's it. I don't know why I stayed on that for so long. Oh, didn't mean to do that. Here we go. Who is on the podium? Why? Ah, the coral is on the podium, and it's actually the most beautiful picture. Blue Rabbit slipped to number 2. Who's come number 1? It must be Excited Chicken. They are back. Ah, how exciting. And I guess, well, no one's in the theatre. There is no theatre. So no chocolate for you, but next week we will have chocolate. Oh, they do too. That is so cute. Oh, I really like that. I've never noticed that before. That's kind of cute. Well, I appreciate that. That's very cute. If someone's done that on purpose, that works really well. Okay, good job. How is everyone feeling? How is everyone feeling? How is everyone feeling? Question 8 was what was wrong, and it's the fact that it wasn't freeing all the nodes. It left one node. That's what was the issue. So it didn't delete the very last node, which means that you've leaked some memory. And so let me show you what happens. We've talked about that last week, and then then I'll talk about what an exam question looks like. So in the lecture yesterday, not last week, someone asked me, oh, what happens if you don't, if you just leave the nodes so the way that we can check, and the way that you'll be checking in your assignment too, whether or not you've deleted all the nodes and everything is good, is you will run the leak check command. So I've got this right now in my main, right? So just using the same file that we used yesterday. And so that means that every node is deleted right now. Yeah, well, hypothetically, we hope so. So I'm going to comment it out, and I'm going to save it, and I'll show you what happens. So I'm going to compile, and then, so I've compiled it, and then I'm going to run it. And then I've run it, and something hasn't happened, which I wanted to show you. And is it because I've got the wrong files open? Who the heck knows? Am I in week 9? I'm in week 9. Oh, of course, because I haven't compiled it with leak check. We're all good. We're all good. Okay, so compile it with the leak check command. So leak check, and then ll.c and main.c. Okay, so when I compile it with the leak check command and then I run it, what happens is at the end of my compile, or at the end of me running it, what I'll get is this error which says freeze not called for memory allocated with malloc in function insert 42 after odd in LLC at line 182, right? So one of my functions is not deleting nodes because I'm inserting nodes. So anything that inserts nodes and malloc some space is going to have this issue. So then if I uncomment this function, which delete all nodes at the end, okay, and I do it again, so if I run the command, if you want, I can do it with O. There you go, if that makes everyone feel it's really just, and then I'll run it again, okay? And then if I run it again now that I'm deleting all the nodes and all of that is in there, I no longer have that error, right? Because now I'm deleting every single node. Okay, how's that? I can compile and run at the same time as well. I can do all sorts of things from the command line. It's all about how lazy I feel. How does everyone feel about leak check? Is everyone happy with leak check? So with linked lists in the exam, you do not need to leak check. We will delete all the nodes for you in our main. Okay. You don't need to do that. Okay. So let me show you. I'm going to go now to the folder. Oh, I haven't finished that. Okay, I haven't finished my insert head to tail. Let's just hold on to that for a second in our minds. We can go back to it if we want. Can I go to the delete all function? I sure can. Delete all, delete largest, delete all. So the delete all function will go through the whole list So current is not equal to null, which means it will go back out to the very last node, and it will go past the last node and delete all of those nodes one by one. Leak check, what it checks is that any malloc is accompanied by a free. So anywhere that you've used malloc to create something, you've then used free to deallocate that memory. So that's what leak check does. So leak check basically tests that for every malloc you have a free, because they go together. Yeah, because you are the one that are in control of the memory. I was gesticulating wildly and I realized my camera was not on. Okay. Does that feel okay? Can we poll it? Do you need to do free in CS kiting? You will. There's a whole stage which just involves deleting things. And that's when you will be using a lot of free. And that's when you will really need the leak check command, because it will help you to see where you might have forgotten, you know, that you've actually got a bit of memory that you've malloc still there. Yeah. Okay. I'm going to leave, just because it's 3:30, I'm going to leave the head to tail for a second. Yeah, stage 3 is where we usually delete things. I'm going to leave this for a second, okay? And I'm going to go to show you what the exam question will look like. Oh, great, there's a poll. Well, you will still be doing the freeing, but you'll be doing it in the stage where it's required. Yeah, so we prompt you to free all of that. You don't have to think about it yourself, basically. Pretty okay. Just lost in general. That's not a nice one. I hope not. A few people doing great or pretty okay. That's good. I like that. Do you have to free in the exam? If you delete some nodes, you might have to free in the exam. It depends if the exam might have inserting or deleting this time. But you would free if you were to delete a node in an exam. Okay. I'm going to just go through and show you what an exam question might look like when you get to it. Okay, so one up, and then we'll go into exam practice. You can see them all now. How amazing. Okay, I've done a few little, so you will only free in the exam when you're deleting a node or when the question explicitly might ask you to. Yeah, so I do have an insert. So let's say you get a question, okay, and the question might look something like this when you pull it out, okay? That means this is your starter code in the exam, okay? So what I mean by that is in the exam you will get, for those first 4 questions in particular, okay, so the hurdle questions, you'll get the definition of a node. You might get some hash includes. Feel free to use other hash includes. We will specifically tell you not to use a standard library when we don't want you to use it. So for example, for question 9, we will often tell you do not use string.h. You have to write all the functions yourself, or you will get 0, and that will be in bold and it will be in the assumptions of the questions. Okay, so you don't have to worry about if you're specifically told not to use a library, then you don't use it. Otherwise, the world's your oyster. So you'll get something that looks like this, where that's the function that we want you to do, and we'll have a comment in there that says, put your code in here, remember to change the return, and a short description of what you want to do. Then there's going to be a section that probably says, do not change the code below, okay? So, and below that, you're going to have the main function that we use to test your question. And what you will also have is that we create the linked list from what you put on the command line. If you want to test your own question, I'll show you how to do that. But this allows us to test it all, right? So, and we print it out for you, which means you cannot make a printf mistake. So you don't have to worry about what it looks like. You don't have to stress that you're going to, have one less new line or a space missing or whatever it is, right? It's all, we do it for you, the printing. So this function you'll see quite a bit in the linked list question, and you don't have to understand it, you don't have to know anything about it, but this is a function that we use to convert a linked list from the command line to a linked list that you work with. All you need to know is that you will need to write this function that actually does the thing that we want you to do. So, and the main function, again, you don't modify anything in the main function. What the main function allows us to do is it just allows you to call and send something out. So it allows us to create a linked list from the command line arguments, and then it allows us to call the function that we want and to print the output. And we use it in testing. By the way, if you just delete it, we can still test your code. So don't delete it. Do not change the code below the line. So should we do this function over here? Should we do an insertion, or should we do something easier to start with? How are we feeling? Something easier to start with, or insert into a linked list? What are we feeling? How are we going? Talk to me. Give me something. Should we do the insert? That's like a question 3, 4. We're skipping question 1, 2. Yeah, so if you have an array question and in it is a sample array, feel free to change the values, which we'll do on Monday, okay? We'll change it up and I'll show you. Okay, let's do the insert now. And then we can work from the insert. We'll go backwards. We'll go to an easier question. It means we'll do the harder question first. All right, great. So basically insert a new node into a sorted linked list, so you don't have to worry about sorting, maintaining the sorted order. So for example, if you have a linked list with 3, 7, 10, 16, and you want to insert an 8, that 8 will go between the 7 and the 10 because it's greater than the 7, but it's less than the 10. No, you don't have to change the array back to the sample values that were provided. You can leave it as whatever. We don't care what's in there. That's not what we use for testing. We put in our own main function when we test. We remove the main that was in your code. Yeah. Okay, great. So what we're trying to do is, let's say we have something that looks like this. Let's draw this out. So we have something currently that looks, I'm just going to use that examples there, 3, 7, 10, 16. I'll give some fake memory addresses. And that means that this is B, this is C, this is D, and this one is null. Okay, great. So, great. We've got something that looks like this, and then we want to insert the number 8. So if we are to go through with the steps that we would need to do, okay, let's say we need to insert sorted, and we give it the value, we give it the head of the list, and we give it the value 8. This is the head of the list, so we provided the head, and then we provided an 8 to insert. So what will be the first step that we need to do when we do this function? Okay, have we got a node to insert in yet? What would be the first thing that we need to do if we need to insert a node? Yeah, excellent. We need to malloc and we need to create the node, right? So the first thing we always do when we insert into a linked list is we create the node. Okay, so number one step we want to do is when we want to create the node. So we're going to call malloc and we're going to make enough space to have a node and we're going to initialize it to have some values. Yeah, so let's do that first. That first piece of code to start with is going to be that we get a new node. So I'm going to struct node, new node, and I'm going to malloc some space, the size of a struct node. Okay, so what that does is that allows me to get some space, allocate some space, and it allows me to create that node. Okay, the node has nothing in it, so this has just allowed me to create my bases for the node, but now I need to initialize that node, right? So I need to give it some values. So we're going to say the new node needs some values. So the new node data is going to get the number that I want inserted. Okay, so the new node data is going to be number. And the new node next is going to get null on it because the node is not attached to anything yet. Yeah, the node is just a node with no attachment yet. So we've got our node now. Okay, so step 1 is done. In the exam, in a question that's worth 12 marks, this would be the first step. So the first few marks would be making that new node. Okay, so the first few marks would be making this node. Okay, great. We've got a node. I'm now going to need to traverse. It would be worth probably about 2 marks. Okay, you've used malloc and you've initialized the nodes. Great. So now I want to be able to traverse through and find where I need to insert it. Okay. Now, right now, this list is full, but always I want to think about the cases where this is not happening. This is just your regular run-of-the-mill case where it goes somewhere in the middle between 2 nodes. But you always, when you're inserting, should think what happens at the head of the list. Does it work? What happens, at the tail of the list? Does it work, my insertion? And so on and so forth. So step 1 is always creating the node when you're inserting. Okay, so step 1, we create the node. Step 2, when you're inserting in, think about what happens in an empty list or when you insert at the head of the list. Okay, all right, we're going to leave that case because our drawing right now, or our diagram, doesn't account for that case. But we could do it actually. Let's just do it so that we don't forget it. How do we check if the list is empty or if the value is at the head of the list that we need to insert it in? How do we check? No, let's just do one thing. How do we check if the list is empty? Let's do the list is empty. How will we check if the list is empty? Yeah, we're going to check if head is equal to null. Where am I typing? I don't even know where I am. Okay, so I'm going to do if head is equal to null. That means the list is empty. And if it's equal to null, that means that I'm going to have my new, well, I can just return my new node. Yeah. And that means I'm just returning this node that I've just created, which is going to have the data and the next is null. So it works perfectly. Okay, this was empty list. I haven't thought about this yet. So let's leave this one for a second because we want to see it in a diagram first. Now let's do run of the mill, in the middle, insert. Okay, great. So let's run through and we will find out where it needs to go. So in our diagram, we would want to insert the 8 between the 7 and the 10. So we would want it to go over here, which means that what we want to do is we want this next to point to our new node and our new node to point to this one, right? So we want to find this current node over here, right? We want to find the node after which we will insert it in. Okay, great. Let's do it. So we are going to need to traverse the linked list, and that means that we're going to have a current pointer and we're going to set it to the head of the list so that we're ready to begin our traversal. Okay, so now I'm going to do my while loop. Oh God, with some bonus extra things. And I want to get to the node at which point I'm going to insert into the linked list. Okay, so current is equal to current next is what allows me to traverse to the next thing. So now I'm going to have two things in here, and I'm going to have the things is going to check that I haven't reached a null, so I haven't gone past the end of the list. Okay, so I'm going to check that my current next is not equal to null. So I'm going to check that I haven't gone to the end of the list, and I'm going to check for my condition, okay? And my condition is going to be that, yep, so someone's put in the chat, perfect, is going to be that my, okay, you want to go to current, we can do that, and then we can see, and we can talk about what the issue would be with this. So if we're going current data has to be less than value. So it has to be less than this number over here that we've done. Okay, now think about it this way. When I exit out of this loop, if my loop condition is set to this, that means that when I exit out of this loop, my current is going to be equal to null, or my current data is going to be less than number, right? So what that means is if I now do any connections, okay, then what that means is I'm going to hit a null, right? I'm gonna dereference some, I'm gonna try and access some memory that is, you know, nothing there, right? So there's two ways to go. Either I can keep track of current and previous, and then I can connect with previous. Yeah. Or what I can do is I can always be looking at the next one after it, right? So I can be checking whether, let's say, current next is not equal to null, and then I'm also going to check here that current next data is less than the number. And I'm going to move along, and that means when I exit, I'm not going to be in this situation where I'm standing on a null pointer. So if I've gone through now, I'm going to insert after this current, right? Because I've checked for the next one. So that means my current is standing here. So I'm going to now insert. So what I want to do is I want my new node next to point to current next. Yeah. And then I want my current next to point to the new node. So if I do that insertion, I'm going to do, and the order does matter. Okay, so my new node next is going to be equal to the current next, because you want to do this before you change the current value. And my current next is going to be equal to the new node. So what I just did there is I drew these two lines. First I did new node next, so this next is going to point to the current next. And then I did my current next over here is pointing now to the new node that I've just created. And then instead of null, don't forget to change this, I'll return the head of the list. Okay, let's try it. It's not going to work for all cases, but let's just give it a whirl so we can see what's going on. So let's compile it. Oh, I can't. No, that's way too much. Okay, so it compiles. So now when I run it, okay, what I'm going to do is I'm going to give it a linked list on the line. So the way that we were practicing with is 3, 7, 10, 16. So I'm going to go 3, 7, 10, 16. And what was the first? The first thing was the value. Yeah, so go back, Sasha, go back. Okay, So insert 8 into a list with 3, 7, 10, and 16. And it's done it, right? It's done it between the two nodes. Okay, now you need to try different things to see if it will work for all cases. So we're going to try inserting into an empty list, which we did take care of. We did it over here. Think about what happens in an empty list. So if we try insert into an empty list, it's just going to insert that node and everything's okay. What else will I try now to try and break it or to try and see if it's actually working? So we're inserting the node into a sorted list, and in the question, the 8 is the value I'm inserting, and then this is the list that I'm giving it. Okay, confused? Okay, so what we're doing is I'm giving it a list. The list is 3, 7, 10, 16, and I'm asking it to insert into the list to maintain the sorting of the list, right? So if I have an 8, it needs to go after the 7, but before the 10. So the first value I give it is the value that I'm inserting, and then I'm giving it the list that I want to insert into. So try giving it one item. So I've given it a 1, and it's inserting at the tail, fine, okay. So it's being done via command line arguments, but you don't have to worry about it. In the exam, we take care of that, okay? So you assume that the given list is sorted already, and you will be told that assumption in the exam as well. You're not going to be asked to do two things in a hurdle question, right? I mean, you're not going to be asked to sort the list, but also to insert into it, plus do another 1,000 things. No, you will assume that the given list is sorted and you will be told that assumption. Okay, try to insert into a linked list that contains that value. I will try that. Okay, that's not really that great what it's done. And what happens if I want to insert before, right? What happens then? Well, it's done it. Has it? No, it's not maintained order. Right? So it's not maintaining the order when I have to insert at the head. So the head broke it. And if we were to check it, look at this. If we have 11, 12, 13, so it would need to insert the 8 at the very head of the list. Randomly, it's just shoveled it over here. Okay? So that means you've got a lot of the marks, but not all the marks, because you've missed one case, edge case. And that edge case is what happens if it's the very first node that needs to be inserted. Okay? So we need to think about this case here. When you insert at the head of the list, what happens then? Yeah? What would be the condition for that? This is a 2-dot question. That's what I mean. We're inserting. We've started in the harder question. 2 dots. I'll calm you in a second with a 1-dot question. Should I leave you to try and do this on yourself, or should we do it together? So if I want to insert at the head, so that means if I've got a new list that looks like this, so I've still got this node, this 8 node, okay, and I've got a 9, a 10, blah, 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 blah. I want to be able to make a new, this to go to this, yeah? And then this would become the new head of the list that I will then return. So what would be the condition that I check? I need to check for a certain condition. And then, you're right, my new node next. So this bit here, new node next, is going to point to the head of the list. Yeah? So it's going to point to the head of the list. And I'm going to return the new node because it's now the new node, the new head of the list. Okay, So here, this condition, what will it be? We need to check whether that number that we're inserting is what? Is less than, so we've done 1, so it's going to be at the head data. Yeah? Should we try that? So let's compile it again. And let's run it, and let's insert 8 into a list with 9, 10, 11. Okay, so that's working. What about if we just do it with 1 item? Great, that's working. So the only thing that's not working is when it's, what should it do in this case? We haven't actually taken care of that case, right? And there's no assumption for this case. So if there's no assumption and you haven't been told what to do, you don't have to worry about it in the exam, okay? There's not going to be a trick thing that's then going to test your understanding. The spec is very specific, okay? And yes, we can add it to this condition. We can say if head is equal to null, how can we add it? We can add it. Yes, we can. Because it's really kind of, yeah. So we can say if head is equal to null or the number is less than head. So sometimes when you're just starting out, code is easier to understand if it's just in sections, right? But you can absolutely do like this. And this will do the same thing as this. And that means you're checking for 2 things all at the same time. Okay, so it's doing 2 things at the same time. So if we compile it again and we run it again, everything is still working. Yeah, so our new node next is pointing to the head. The head is equal to null, right? So new node next is already null, right? So when we created this is null. So if I point it to null, it doesn't matter, right? Because the node, when we access the new node next, that's got some memory in it. But if I point it to null, it doesn't matter if it's already null. But if it's not null, because it's got an OR, so the head might not be null, then it will point to the actual head of the list. Yeah? Maybe? How does that feel? Can it tell me how it feels? How are you feeling about it all? I think I had... So this is kind of what a question looks like, okay? I tried to like write out a little bit of a problem and what it would look like in the comments. It'll tell you like find whatever you need to find. It'll give you an example, exactly the same as your labs, right? It will also give you a testing. It will give you what it's meant to be doing. And then it will also give you some assumptions at the end of the question, just like we do it now normally. And it will tell you what it returns. Don't change the linked list. Do not call malloc if that's applicable, right? It'll tell you a whole list of instructions. Okay, so this is more like a 1 dot question over here. So this one, the list range, so anything that's insert or delete is 2 dots. Anything else, so something like this, find divisible should return the number of items in the list that's divisible by whatever this number is, right? That's a 1 dot question. It means you traverse the list and you find any item that is divisible by it. And hopefully you can do that in about 10 minutes, 5 minutes. And again, same thing, right? You don't have to worry about anything that happens in the code below. All that happens is that we convert output that you give in command line to a linked list so that you can test your code. Yeah? Okay. I can't believe how fast this lecture has gone. How are we feeling? Okay, so the plan for Monday, and it might change. Okay, I'm going to pull a poll up on the discourse, and you can leave me some feedback as well. But the plan is what I would like to. I'm going to poll what kinds of questions you would like to do on the Monday. We're also going to have a little guest lecture, a little 40 minutes from a guest this coming Monday. And oh no, I don't have oh no. You can't leave me feedback. I don't have it this time. I don't know why. I decided I would like some feedback. Okay, but things are going okay. I'm going to do a poll then in the forum, and you can come on the forum and tell me what kinds of questions you would like to see and work through. And I'm going to do some array ones. And then on the Tuesday next week, I plan to do some harder questions, you know, things like strings and things like that. Quick question, if we have an empty list and we do head is equal to new node, do we return the head or the new node? So you've assigned the address that's sitting inside new node to the value of the head. So you can return head or you can return new node. Yeah. Yeah, so A to I it converts things to numbers from an ASCII string, basically. It's just for making the command line arguments into a linked list. You don't have to understand that function, but that's what it's doing. It's helping us, and it's helping you by letting you do some testing. All right, well, I hope you have the most lovely rest of the week. It is week 9, and good luck. I hope it all goes well, and I look forward to seeing you in week 10, which is going to be the last week of term. By this stage, you would have finished your whole first term of university, which is so exciting. I can just see Bella pasting the My Experience link as well. Thank you all so much for tuning in today. Please let me know if you have any questions, okay? Ask anytime. I'm always happy for questions. And yep, I'll see you later. Have a great week. Bye, everyone. Bye.